Okay, I'm on the app called My Mind. It's an app that you can get on Google Play. And I'm going to go through the profile of the Beeman 7.7 wad cutter and how it applies to the Daisy 35. So first of all, let me expand the screen here. So we're talking about the Daisy 35 air rifle. And first let's go over some stats that you can keep in the back of your mind while I'm telling you the velocities and the energies. It takes about 2.6 foot-pounds of energy to stick flush in a pine board, and it takes about 1 foot-pound for a pellet to go like that to go through a soda can because of its shape. So keep that in the back burner of your mind for distance when I show you the distance and the foot-pounds and stuff like that. So what we're going to go to next is we're going to go to the individual pumps to see what we're getting. And as you can see there, I labeled it 7.7 wad cutter. So what I want you to look at is there's three areas here that I want you to look at. The first area on the left there is the number of pumps. So I got one pump, for instance, on the top. The second area is 195. That's the FPS. And the third area here is 0.65. That represents the foot-pounds of energy. So what I'm going to do is I've already showed you one pump what it's doing, so I'm just going to scroll all the way down to 10 pumps and show you all the energies and feet per seconds here. So there we go. You can write this down, or you can also screen cap it too if you want to do a screen capture or whatever. But this is some data that I collected off my chronometer when I was taking samples and stuff. So these velocities and energies, these are point blank range. And as you can see, if we go up here now and look, we can see that we need about 2 pumps for a pop can at point blank distance. We should have at least about 2 pumps for a pop can because that's 1.5 foot-pounds of energy. And to stick in a pine board, we need probably, say, 3 to 4 pumps or something like that to stick in a soft pine board. So that kind of gives you an idea of what kind of energy you got. So what we're going to go to next is the 10 pump figures into ballistic coefficient and what you can expect at certain yardages. So here we got 10 pumps, and we're going to start off at 25 yards. At 25 yards, we have a velocity of 406 feet per second, 2.82 foot-pounds. That means that that pellet at 25 yards should stick flush in a pine board, which is pretty good for 25 yards, I would say. But as you know, the further you go, the less energy you're going to have. So if you look down here, when we get to 75 yards, we got 0.81 foot-pounds of energy, which means that pop can distance for this particular rifle would probably hover in between the, maybe the 60 and the 70 yards. Now, this is just the wad cutter. This is just speculation of what you can expect. You know, there's a plus or minus foot-pounds, obviously, and depending on the wind and other factors, whether a pop can, whether it's going to go through or not at 75 yards. So we got 100 yards here, and as you can see, it's 0.3 foot-pounds of energy, not a whole lot. That's about half of a Daisy Red Ryder, energy-wise speaking. You still got 159 feet per second after 100 yards. But if you're going to go the distance, you have to know what kind of energy you're getting at that distance. And also you have to know what kind of grouping you're getting, because if you can't hit something at longer ranges, then it makes no sense to shoot at longer range. So for instance, if we got 10 pumps groupings with 10 shots here, I'll show you these. So once again, we got 10 pumps, and the groupings are 10 shots per cluster. And if we're going 10 yards and we get 1 inch center to center for them 10 shots, then the law of doubles, which means when you double the distance, you double also the dimension of the cluster size. So at 20 yards, you're going to get 2 inches center to center, and 30, 3 inches center to center, and 40, you get 4. so on and so on and so on. To some degree, this works out okay, and then other times it doesn't, depending on wind and other variables like that. But we can be safe to say that if you look at 30 yards here, 3 inches center to center for 10 shots, and let's say you got a pop can which is 2.6 inches across, we could say that the Daisy 35 is good for whacking pop cans at 30 yards, and you should be able to hit the cans almost all the time at 30 yards. Now, if you're going 40 yards, 50 yards, yeah, you can still hit them, but I'm talking about 10 shots. I'm not talking just about a one or two lucky shots. So we're talking about consistency here. So for a consistency rating for the Daisy 35, it's in between probably 25 and 30 yards for consistency of smoking a pop can. So although you could take shots out to 40 yards with probably soup cans, which are a little bit wider. But anyway, and soup cans will be much wider than 2.6. Some of them are over 3 inches, so 30 yards that'll fit in. But I just thought I'd show you the profile of the 7.7 grain 7.7 grain Beeman wad cutter inside the Daisy 35 with 10 pumps. So I thought you'd enjoy hearing about the profile that I made on this particular pellet for this rifle.